we will continue with our electricity lecture, and building on what we learned last time. I think the last thing that you did with me was I is equals to NAVE, which is the one of the defining equations for current. Please remember one thing. I'm reminding you that N is the number of electrons per unit volume. It's not just the number of electrons, and therefore the unit will be m minus 3. The rest you're all very comfortable with, but this is one thing that you mess up mostly. All right. Well, we need to build on this concept of current, and I'll take you back to that wire. Okay. Now, when you consider that wire, and talking of that wire, what we do is we apply a potential difference V across that wire, okay? And the length of the wire is L. Like I mentioned yesterday, this is plus, this is plus, this is minus, this is minus. So if you have an electron, which is over here, the electron is going to accelerate in this direction towards the positive terminal. Now, this wire has an area A, right? And a length L. So, there's a construct which is called electric field strength. Now, right now, I'm not going to go into a lot of detail of electric field strength, but all you need to know is that electric field strength is defined as the force per unit charge. All right, this is the force per unit charge. And electric field strength is also defined as the potential difference applied divided by the distance between the two terminals. So you've applied a potential difference V between these two terminals. The terminals between length L, so it's V over L. So V is the potential difference between the two terminals, and L is the length between the two terminals. Two terminals वो होते हैं जो जहाँ पर wire terminate होती है, wherever the wire terminates. So that tells you that the unit for electric field strength could be Newton per coulomb from the first equation, and it could also be volts per meter from the second equation. V over L से V per m V m minus 1 आ सकता है, और F over Q से it can be NC minus 1. I hope you are with me so far. Now, considering the same piece of wire, okay, you had also discussed that these electrons are moving in this direction, so there will be a current, and the current will be defined as NAVE or NAVQ, whatever you are very comfortable with, right? These electrons, each electron moving in this direction is experiencing a force F, right? So I can say that F is mass into acceleration, correct? Where m is the mass of the electron and a is the acceleration. We can also break it down further, and we can say that this acceleration actually is force per unit mass. Should not be a problem. Then you should also understand that this force is the electric force. This force is the electric force. M is the mass of the electron which is moving. Stay with me in this derivation. It's going to amaze you at the end. Now, this force, F, is the same as this force F over here. So F could be equal to E into Q. So I can write that down over here, that F is equals to E into Q. And if you break down E further, आप E को भी तोड़ो, तो E तो V over L के बराबर है, right? तो इसका मतलब है इस E की जगह I can write V over L. So पहले मैंने F की जगह लिखा EQ, और फिर मैंने E की जगह लिख दिया V over L. So that means that F can be written as V into Q over L. I hope it makes sense. I said acceleration is force over mass. So I said that the force is E into Q, and then I said E is V over L. Because आप देखें तो वायर के ऊपर जाओ तो you have a voltage, you have a length. I need to see that in that formula over there. So इस force का क्या relation है with the potential difference, क्या relation है with the length, वो आपको यहाँ पे नज़र आ रहा है. And then obviously if you have force and you have mass, then you have acceleration. So ये आ गई आपकी force. Okay. Now if this is the force, then obviously the acceleration would be this force divided by mass. So since this is force and acceleration is force over mass, so you can say this will be VQ over M into L. With me? Great. Moving this slide to the left, sorry. Now, let's apply an equation of motion, V is equals to U plus AT. So let's assume that my particle started from rest, so no initial speed in that direction जिसमें move कर रहा है. So initial speed 0 लेते हैं, rest से start किया. So velocity would be equals to A into T. And what is A? A is over here. This is A. So I can say that V is equals to, please be careful because दो V's आ गए. V is equals to VQ over ML into T. Make sense? So आपने क्या किया? आपने इस acceleration की जगह VQ over ML डाला और ये T उसके आगे वैसे का वैसे ही आ गया. So your speed, your drift velocity is VQ over ML into T. This is drift velocity, by the way, जो इसको पीछे हम derive करके आए थे in this equation, which was I is equals to NAVE या NAVQ. All right. Now, once you have this speed, which is V, you can plug it here because it's the same thing. ये drift velocity थी. Drift velocity को उठा के आप यहाँ पे डाल देंगे. So, when you pick it up and you plug it here, you will get I is equals to NA. Now I'll put the substitution over here. VQ over ML instead of your drift velocity into time. Right? और उसके आगे E. I hope you're with me. Achha, this is not necessary at all that you put T outside. You can even remove that from there and you can put the T inside and I can simply have the E outside. It makes more sense. So, आपने किया क्या? आपने सिर्फ speed को उठाया और speed को यहाँ पे डाल दिया. You got VQT over ML और ये आ गया NA. And this is your expression right now. So in this expression, I want you to note that this is Q and this is also charge. And there, since they're the same thing, I can write this as Q into Q या E into E, whatever you want to call it. So I'm going to collect these two together. So I can get Q square or E square, whatever suits you better. So इसको हम और simplify करते हैं. And let's write down the equation again in a neater way. So you will get, let's say, E square, okay, into N भी नज़र आ रहा है, T भी नज़र आ रहा है, okay, you have A नज़र आया, you have V, right, and you have in the denominator, you have M and you have L. So E square NT AV ML. Let's cross check so you don't get confused. Q and Q, I wrote that as E square. N T A V and V divided by ML. Now, there's a reason why I wrote like this. The reason for that is that E square NT and M, these things that I've put in the little weird circle are dependent completely on the wire. Nature पे dependent है. देखो, cross-sectional area, you can change yourself. Voltage, you can change. Length of the wire, you can change. But you cannot change these things. These are by nature. Now because it's very hard to write this over and over and over and over and again, I will put them together and give them a name, sigma, which is conductivity. So अब से हम ये जो E square NT over M है, इसको E square NT over M को हम sigma बोलेंगे, conductivity. Alright, now that means in my previous equation, I can rewrite that equation as I is equal to sigma AV over L. Right? Now, bear with me. You're almost done. Almost done. I know this can be a little overbearing, but you're almost there. Now, there's a concept called resistivity. And resistivity, rho, is 1 over sigma. Alright? So there's a concept called resistivity rho, and that also depends on the type of wire you have. So resistivity is 1 over conductivity. So conductivity was this thing. Resistivity will be 1 over conductivity. Where do we need it? Just have a look. If in this equation, I make V the subject of my equation, I will end up getting V is equals to Li or IL over sigma A. So V को इधर रखें, L को इधर ले आए, so IL over sigma A, this is what I end up getting. Please have very good look, because although you might feel a little overwhelmed right now, but you're done, you're almost there. L, length of the wire, is a constant. A, cross-section area of the wire, was a constant. Sigma, conductivity, constant, depends on the material. So if all these three things are constant, let me put them together. If all of them are constant, then I can say V is proportional to I. And basically, you're staring at Ohm's law. Isn't that amazing? That's the first thing. That's the first surprise for you today. The second surprise for you was that this fraction, the same fraction, V is equals to IL over sigma A, इसमें एक और चीज भी छुपी हुई है. Let me write it down again. Now, if in this expression I bring I down, I'll get V over I is equals to L over sigma A, right? And from O levels, you know what is V over I. V over I is resistance. What is 1 over sigma? So if you did not understand what I just did, have a look again. मैंने ये किया, I said V over I is resistance. Now, what I want to say is that L over A के साथ हम 1 over sigma भी तो लिख सकते हैं, यूं करके. Should not make you unnerved or should not make you uneasy, because it's the same thing. अभी भी sigma और A आपस में multiply ही हो रहे हैं. Sigma और A multiply हो रहे हैं और L और 1 multiply. So what is 1 over sigma? 1 over sigma is resistivity. So I can write 1 over sigma as resistivity. So V over I was R, L over sigma को हमने यूं लिखा, और 1 over sigma को मैं लिखता हूँ resistivity. I end up getting another expression, which is rho L over A, because this thing is rho. So वो rho के साथ L multiply हुआ, A divide हुआ, and I'm very sure you have seen this formula before as well. Or if you haven't, then you must have learned the concept in this way in O levels, that you should have remembered or memorized the fact कि अगर आप वायर की लेंथ छोटी करें versus वायर की लेंथ बड़ी करें, so the resistance is always proportional to the length. So if let's say this is R1, this is R2, R1 will be less than R2, provided that their area is the same. The second thing that you might have learned in O levels is you use a large pipe versus you use a smaller pipe. Remember, the smaller the pipe, वो electrons उतने ज़्यादा टकराएंगे, resistance उतनी ज़्यादा बढ़ेगी. So that tells you that the resistance is inversely proportional to area, and that is exactly what this equation is also telling you. Resistance has an inverse relation with area, and resistance has a direct relation with length because resistivity over here is constant. Lovely. I'll see you in the next class.